So Faraday is all about the change. It's all about the change in the flux, and it's all about the change in current. So Faraday recognized that if you change the amount of flux that is going through a magnetic circuit, then the voltage induced will be relative. The amount of voltage that will be induced is relative to that change in flux. So Faraday is a person who said that voltage is going to be equal to the change in flux over the change in time. So Webers per second. And the formula for that, of course, is just voltage is change in flux over change in time. And this is, this is a calculus way of saying it. Small rate of change in flux over small rate of change in time. That's what the small d's mean. So instantaneous voltage, we can calculate the instantaneous voltage if I then take the small change in flux over small change in time, and I multiply that by the number of turns that are in each coil. So here we go. I have my primary coil. It has n turns in it. I have my secondary coil. It has n turns in it. But if I look at the voltage over here and the voltage over here, well, what's common between them? N is different. Voltage is going to be different here, but it's the same magnetic flux that links them, because this had flux, which induced flux over here, and these pink lines here are the flux. So every single turn here, let's say there's 1, 2, 3, 4 turns over here, there's going to be the same amount of voltage per turn, because those lines of flux are cutting across each of those magnetic conductor, or each of those current carrying conductors. Let's say there's 4 over here and there's 1, 2, 3, 4 over here, then I would have the same amount of voltage on that side, because it's the same number per turn. However, if I have less N1 and I have more N2, then I'm going to have more voltage over on the secondary side than I did on the primary side. It will have less current though. So we also know this formula, that the amount of flux that is induced inside ferromagnetic material is equal to the ratio between the induced the force that induces that, which is my magnetomotive force. It's a force that induced that that magnetism to actually happen, divided by the amount of resistance that's in that material. We know this formula. We know that Fm is also equal to N times I, the number of turns times I, and then if I look at this formula with these subbed in, I notice, well, N, I don't change the number of turns that this transformer is built with, and I don't change the reluctance of the material. It's a function of the material property, and I'm not changing that material. And this is how Faraday can draw the conclusion that flux is directly proportional to current. So Faraday's law in general says the change in flux is directly proportional to the change in current, and that's what Faraday said.